Assalamu alaikum students. Today we will start chapter 8 waves. First MCQ is the mechanism by which energy is transferred from point to point is. So it is called a wave motion. The mechanism by which energy is transferred, this is called a wave motion or progressive waves. Here we have two types of waves. Stationary waves in which no motion of waves occur, and the progressive wave in which waves moves or a motion of waves is called progressive wave. And progressive waves have two types, electromagnetic waves and mechanical waves. So due to progressive wave, the energy is transferred from point to point, and these waves are also called wave motion. So here option A is correct. The wave motion is also called progressive waves. Second, which of the following waves are medium independent? Now we have two types of wave. One is electromagnetic waves and another is mechanical waves. Okay, mechanical waves. Electromagnetic waves are independent of the medium. Okay, independent of the medium, while mechanical waves is dependent on medium. Okay, so here sound waves is mechanical waves. Water waves is also mechanical waves because it required medium is water. Standing waves is also mechanical waves because it also required medium. And sound waves required air is medium. Here look, thermal waves. This is medium independent. Okay, thermal waves are medium independent. Like look, take the example of sunlight. Sunlight between earth and sun, there is no medium, vacuum is present, but still the sunlight reach the earth. So it is the example of thermal waves. So here the medium independent waves are thermal waves. Third, the waves that required a medium for its propagation are. So we know that mechanical waves required medium for its propagation. And look, water waves and sound waves are the types of mechanical waves. Okay, so here option D is correct for this MCQ. Next one. Transverse waves cannot be generated in. So here guesses. For transverse waves, the medium must be elastic and they must exert force on each other. The molecule of medium must exert force on each other in order to produce the transverse waves. Okay, but here in gases, the molecules are far away from each other. Therefore, it cannot exert force on each other. That's why transverse waves cannot be generated in gases. Look, these two are the condition of waves. Okay, transverse waves. The particle must be elastic and the particle must be dependent on each other, like they must exert force on each other. So here guesses it's the correct answer. Look at the 5. The speed of transverse waves in a string under tension T and mass m per unit length of a wire is V. So speed of transverse wave is given if the string is replaced by another string of radius half of its original string, then the speed of waves become. Now if the radius of the string become half, then how much the speed will change? Okay, so let's find this one. Now look at here. We know that for transverse wave, the formula for finding the speed of sound is this one. Okay, sorry, not the speed of sound, the speed of waves. Okay, this is the formula for transverse waves. Now Vt is equal to tension divided by m, where m is the mass per length. Okay, it is the linear density of the string. Okay, linear density, mass per unit length. Now we can write it like m divided by L. Now bring this L here, so you will get Vt, V transverse is equal to T tension length divided by m, and take the under root. Now here we know that the mass of the string is equal to rho V. Okay, the mass of the string is equal to rho V. Now look, we know that density is equal to mass per unit volume. Now bring this volume here, you will get mass is equal to this density and volume. Now we know that volume is equal to area multiplied by length, and area is equal to, first cancel this length with this one. Okay, and area is equal to density pi r square. Okay, area is equal to pi r square. Now look at here, it will be, if we apply root on r, then what will happen? It will be 1 over r. Okay, 1 over r under root t divided by density and pi. Now keep one thing in your mind, that if this expression were in addition or subtraction form, then you can't cancel this r square with this under root. Okay, now it is in multiplication form, so you can cancel it with under root. So it will become 1 over r t divided by rho pi. Okay, now if we keep this expression constant, then what will happen? Vt will be equal to inverse r. Okay, look at the MCQ. They have kept all the tension, the mass and mass per unit length constant. Okay, the density is also constant, but only the radius is changed. Okay, now this expression is constant here, only the radius is changed, so we can write it like V transverse is equal to 1 over r. Okay, now look at here, according to the given condition, look, V transverse is equal to 1 over r divided by 2. Now the new velocity, the new speed of the transverse wave is equal to 1 over r divided by 2. Look, the radius is half of its original radius, okay, r divided by 2. Now we know that Vt new, speed of transverse wave, the new speed of transverse wave is equal to 1 over r divided by 2, and you should divide it with the original waves, with the original speed of the wave, okay. So it will be like divided 1 over r. Now look, here Vt is equal to 1 over r, okay, the original velocity is 1 over r. Now you can write it like divided by 1 over r. So it will become like Vt new is equal to Vt original, okay. Now bring this 2 here, okay, it will be like 2 divided by r. Cancel these r, okay. When we change this division into multiplication, it will be like r divided by 1. Now cancel these 2, so you will get 2 divided by 1. Now bring this velocity original into here in multiplication form, okay. You will get Vt new is equal to 2 times of the Vt original, okay. Now if the string is replaced by another string of radius half of its original string, then the speed become 2 times of the original speed, okay. The speed of the transverse waves will become 2 times of the original transverse waves. Now look at the options. Look here, option A is correct, okay. The new speed will be 2 times of the original speed. Look at the 6th one. The speed of transverse wave in a string is v, okay. Transverse wave, the speed of transverse wave is v. If the tension is quadruple, means 4 times, then the speed of the transverse waves will be. Let's solve this one. We know that Vt is equal to tension length divided by mass, okay. And we also know that Vt is equal to 1 over r tension rho divided by pi, okay. You should memorize these 2 formulas. So from these 2, here we get that Vt is equal to under root tension. Now if we keep all these as constant, then you will get Vt is equal to under root t. Now Vt new, original new velocity of the transverse wave is equal to 4 times. Look, quadruple. Now apply this 4, apply the under root on 4. You will get like Vt is equal to Vt divided by Vt original is equal to under root 4t divided by t. Now cancel these t and apply the under root on 4. You will get 2 divided by 1, okay. Now bring this one here in multiplication form. You will get the new velocity of transverse wave is equal to 2 times of the velocity, original velocity of transverse waves, okay. Now this one is the equation. Now keep one thing in your mind, that you don't have to do all these mathematics, okay. The shortcut method is that you know that Vt is equal to under root t, and here in the MCQ this must be quadruple, okay. Here the required is quadruple. Now put here 4t. When you apply the under root on 4, you will get Vt is equal to 2. Now you can directly correct, you can directly take the options in which Vt is 2 times of the original t. You have to do only these 2 steps in the test, okay. You don't have to do all these mathematics. It was just for your concept, okay. You should directly take those one MCQ, that option in which Vt is equal to 2 times of the original velocity. Now look at here, option A is correct, okay. If the tension is quadruple, then the speed of the transverse waves will be 2 times of the original waves. Look, apply these 2 steps, okay, in test. So you will get the answer. Look at the 7. A wave source of frequency 1000 Hz, radiate waves of wavelength 0.10 meter. The time taken to travel 2500 meter is. Now you have to find the time. Look, we know that v is equal to f lambda, and we also know that velocity is equal to displacement divided by time, okay. Now bring this f lambda here in the division, and the t will be here in multiplication, okay. Exchange the places of these 2, okay. You will get this equation. When you exchange the places of time and f lambda, then you will get this one equation. Now you have to memorize this one equation, okay, or you can derive it on the spot in test, okay. It's easy, it will take less time. Now look, the time is 20. Here the displacement is 2500 meter, okay. The distance is 2500 meter. Now look, the frequency is 1000 Hz and the wavelength is 0.10 meter. Now if I multiply this with 0.10, then what will happen? Now first you have to cancel these 0, okay. First step is cancel these 0. You will get 25 divided by 10 multiply 0.10. Now if you multiply these 2, okay. First step is what? You cancel this 0, okay. The second step will be multiply these 2, so you will get 1, okay. Now 25 divided by 1, so you will get time is equal to 25 seconds. Now a wave source of frequency 1000 Hz radiates the wavelength of 0.10 meter. The time taken will be 25 seconds. So look at here, option C is correct. Okay. 8. The energy transmitted per unit area per unit time is, here energy divided by per unit area per unit time, and we know that energy divided by per unit time is equal to power. Okay, so it will be like power divided by area. Now look at here, power per unit area. So here option C is correct. Okay, energy per unit area per unit time is equal to power per unit area. Now look at the next one. A vibrator of frequency 5 Hz produces wavelength of 0.2 meter in a string. The speed of a wave string is, now we know that speed is equal to f lambda. Okay, frequency is 5 multiply 0.2. Okay, now 2 5s are 10, 2 5s are 10, just put this 2 5s are 10. Okay, and now the next step is to count the digits after point. Here 1, the digit is 1 after point. Now put here 1. Okay, the digit is 1 after point, so put here 1, so you will get 1 meter per second. Here the answer is C. Okay, look at the next one. Intensity of wave depend upon, look here, this one is the formula of intensity. Okay, intensity of waves is equal to 2 pi square, amplitude square, frequency square, density and speed. Okay, this is the formula of intensity of wave. You should memorize this. Okay, or you should only memorize that intensity is directly proportional to a square, because most of the questions come in this equation. Okay, most of the questions are on this equation. Okay, if you want to memorize this, then you can. Okay, intensity is equal to 2 pi square, amplitude square, frequency square, density and velocity. Now look, intensity depends upon, option A is velocity of the waves only. This one is also correct because here it is the velocity, and the intensity also depend upon the frequency. Okay, option B is frequency of the wave, so this one is also correct. And here option C is square of the amplitude. Okay, directly proportional to square of the amplitude, so C is also correct. So it means that A, B and C also is all correct. Okay, intensity of wave depend upon velocity, frequency and the amplitude. Look here, option D is correct, all A, B and C. Look at the 11. The error in the speed of sound in Newton's formula occurred due to, now when the speed of sound was calculated by Newton, so he said that the waves are in isothermal condition. Okay, due to which the error arises. He said that the waves are in isothermal condition, due to which the error arises in the speed of sound. Okay, so option B is correct here. And also keep one thing in your mind, that isothermal condition is very slow. Okay, it is slow process, isothermal. That's why the error arises. Newton says that the speed of sound waves is isothermal condition while it is slow. But in reality the speed of sound is very high. Okay, so that's why the error arises. Next, Laplace corrected Newton's formula for speed of sound in air by using adiabatic condition. Now Laplace said that the adiabatic condition is very fast. Okay, and in this process the heat transfer do not occur. Okay, the heat transfer do not occur, and he also said that the air is a very poor conductor of heat. That's why the speed of sound is adiabatic condition, and in adiabatic condition the heat does not flow through a system. Okay, the heat do not conduct, so that's why the correction was due to adiabatic condition. 13. The speed of sound in air at 27 degrees C is 340 meter per second. The speed of sound at temperature of 927 degrees C is. Now look at here. We know that speed is directly proportional to the temperature. First, look at here. We know that speed is longitudinal waves. Okay, for longitudinal waves, the formula for speed of sound is different. Okay, in previous MCQ, we have found the speed of sound in case of speed of waves in case of transverse wave. Okay, not sound. In previous MCQ, we have found the speed of transverse waves, but now we know that sound is longitudinal waves. So in this case, the formula is different. Okay, here it is gamma R T. Here T is temperature. Okay, T represent the temperature and M is the mass. Okay, T represent the temperature in case of longitudinal waves, while in case of transverse wave the T represent the tension. Okay, the T represent the tension in case of transverse wave, while in case of longitudinal waves this T represent the temperature. Okay, now if we keep all these expression as constant, then you will get V is equal to under root T. Okay, now V2 divided by V1 is equal to T T2 divided by T1, okay, under root. Now what you have to do, you have to convert this degree C into Kelvin, okay. This one is very necessary step. You have to convert this degree C into Kelvin. Now T2 is 927 plus 273, so it will become Kelvin, and T1 is the 27 degree C plus 273, it will become Kelvin, okay. Now when we add these two, you will get 1200, and when you add these two, you will get 300. But here look, V1 is also given, which is 340. Now put in place of 340, in place of V1 340, okay, put in place of V1 is 340. So bring this 340 here in multiplication side, it will become like this, okay. Now cancel these 0, and 3 1s are 3 and 3 4s are 12. You will get under root 4 multiplied 340, then it will give 2, okay. This one will give 2. Now multiply these two, you will get V2 is equal to 680 meter per second. Now look at the option B here. Option B is correct. Now keep one thing in your mind, that if this one was 0 degree C, if this one was 0 degree C, then use V is equal to V original plus 0.61 multiply temperature in degree C, okay. If this V1 is 0 degree C, then you should use this one formula, okay. This one is a short formula. But if this is not 0 degree C, like here in this MCQ it is 27, then you should use this one, okay, this one formula. But if it is 0 degree C, then use this one formula. In place of V0, put the original, put the speed on 0 degree C like 340, okay, and plus 0.61 multiply by T degree C. Now in case of this one, you should put 927 and do not convert it into Kelvin, okay, directly put this one. But this formula is only for when T1 is equal to 0 degree C. This is valid only for this condition, when T1 is equal to 0 degree C. Here option B is correct. Now next one. Speed of sound waves in air is 350 meter per second. Its speed in air of density 1/4 will be. Now what will be the speed if the density is 1/4? Let's find this one. Here we know that speed of sound is equal to gamma pressure divided by density, okay. This one is the original formula, and if we want to convert it like this, then it will be here. In case of pressure, P is equal to nRT, okay. Now for 1 mole it will be RT, and you have to convert this density into volume, so it will give you this one answer, okay. Look, this derivation is present in your book, okay, you can do it from there. So velocity is equal to omega gamma pressure divided by density. So if we keep these two expressions as constant, then you will get V is equal to 1 over under root density. And here when the density is 1/4, then you will get V nu is equal to 1 over density divided by 4, okay. You will get this one. Look, we have to find the V nu. V nu divided by V original is equal to 1 over under root density divided by 4 divided by 1 over density, okay. This one, 1 over density. If we convert this division into here multiplication, you will get this one expression, okay. And now bring this 4 here, okay. You will get under root 4 divided by density multiplied by under root density divided by 1. Now if you apply the under root on 4, you will get 2 divided by under root density. Now cancel these 2, okay. You will get only the true answer, okay. Look here, you will get V nu divided by V original is equal to 2 divided by 1, okay. Now bring this here, so you will get V nu is equal to 2V. Now multiply this, the original V, look at the MCQ, the original V is 350 meter per second. Now put here original V, 2 multiplied by 350, you will get V nu 700 meter, okay. Now again, you don't need to do this calculation, okay. You don't need to do all these calculation. What you have to memorize, you have to memorize this one only, okay. How you will do it? Like V is equal to 1 over this one, okay. Here we know that V is equal to 1 over under root divided by 4, okay, under root density divided by 4. You know that when we apply under root on 4, you will get 2, and now bring that 2 here in numerator side, so you will get V is equal to 2, okay. So it means that the new V will be 2 times of the original V. So what you have to do is simply put 2 multiply 350, then you will get 700 answer, okay. You have to know just this one. Now then the next step will be this one. Then V nu will be 2, so multiply the original with 2. So you will get to know that the new velocity will be equal to 2 times of the original velocity. When you know this one, then just multiply this 2 multiply 350. You will get 700 meters per second. Look here, option B is correct, okay? Look at the 15th one. The condition for the constructive sound waves. The condition for the constructive interference, okay? Interference of sound waves is. Now look at the option. For constructive interference, the path difference must be equal to integral multiple of the lambda, okay? This is for the constructive interference, like n is equal to, n must be the whole number, okay? N must be the whole number for constructive interference. And the phase difference must be n 2 pi, okay? The phase difference must be n 2 pi, where n must be the whole number, okay? Starting from 0 and so on. So here option A is correct. Now the maximum possible number of beats heard by sensitive human ear are. So this is 10, okay? The beat will, only the 10 beat will be observed by a human ear, okay? A human ear unable to absorb more than 10 beats, okay? The beats must be, smaller than or equal to 10, okay? The beats must be smaller than or equal to 10. But look here, it is the maximum possible. So the maximum possible is 10. Option A is correct. Like this doesn't mean that beat can't produce above the 10. Beat produce from 1 to above, okay? It can be more than 10, but this is the human ear only heard 10 beats, okay? Human ear only hears 10 or less than 10 beats. But above this number, they can't observe the beats, okay? Human ear can't observe the beats above 10. 17. Two tuning forks of frequency 250 Hz and 300 Hz are sounded together. The number of beats heard by human ear are. Now we know that beat is equal to F2. F2 must be greater minus F1, okay? F2 must be greater than F1, okay? You should take the F2 as greater value. Look, this is 300 minus 250. So you will get 50 beats, okay? 50 beats. So here option A is correct. The beats can't be negative, okay? It's only positive. So option A, 50 beats. Now look. A transverse wave traveling in rear medium after reflection from denser medium meet with the phase change of. Now when a wave travels from rear medium to denser medium, then the phase change will be 180 degree, okay? Now look at here, it's a string. The one end is fixed with the wall and another is in the hand of a person, okay? When he set an upward pulse in this string, then the pulse will travel and come here. Then this pulse try to exert force on the wall in order to move this wall upward. But we know that the wall is rigid particle, okay? The particle of wall is rigid, okay? We know that. So in this case, the wall applied force on this pulse, applied force and opposite force on this pulse. So what happened? When the wall applied an opposite force on this pulse, okay, in reaction to the force of the pulse, because this pulse wants the wall to be moved upward, but the wall cannot move upward. In turn, the wall exert force on it, an opposite force on it, and what happened? The pulse will be like this. The phase will be changed 180 degree. Look, this one is 180 degree change in the pulse. So it will be when a wave travels in rear medium and after reflection from denser medium. Look, it's a rear medium, okay? And this wall is a denser medium. When it reflects from the denser medium, then a phase change of 180 will be occur. Look, this one is present in your book on page 217, okay? The mechanical waves, you should read it here, okay? Standing waves or stationary waves are the result of superposition of two identical waves traveling in the opposite direction, okay? In case of standing waves, one wave come in this direction, okay, like here, and another wave come in this direction, okay? So the direction is opposite, that's why the stationary waves form, okay? So here option B is correct. 20. The point of maximum stress in stationary waves are. Now look here, option A is correct. The maximum stress will be there where the displacement is always 0, and we know that in nodes displacement is 0. Like look at here, this one is node, okay? Here the displacement is 0. This one is node, here displacement is 0, and here the displacement is also 0. So this is because the maximum stress is in this point, okay? The maximum stress occur in this point. That's why here the displacement is 0 and the pressure will be maximum here. The stress and pressure will be maximum in these 2 points. So here option A is correct. The frequency of wave in a straight string of sitar is 200 Hz, okay? If the tension in the string is quadruple by stretching it, then the frequency will become. Now look here, we know that the string of the sitar is clamped at both ends, okay? It is tied at both ends, like its string of sitar, and it is tied at both ends. Now when the frequency produced, what happened? This will give the standing waves, okay? Here the concept of standing waves is applied. When the frequency produced, it will give standing waves. Now let's find the frequency when the tension is quadruple, 4 times. Now look, here is the formula. We know that V is equal to F lambda and V is also equal to T divided by M. Now look, we know that in string the transverse waves occur, okay? So this is the formula of transverse wave. Let's combine these two equations. You will get F lambda is equal to under root T tension divided by M. Now bring this lambda here, so you will get F is equal to tension divided by linear density multiplied by 1 over lambda, okay? This is present in the stationary waves, okay? In order to find the frequency, so this one is present in the stationary waves. Now look, you have to memorize only this one relation, okay? You have to memorize this one relation, that frequency is equal to under root T, okay? Look, in the MCQ, all this one and lambda and the linear density is constant, but only the change come in the tension, okay? They have changed only the tension, so you have to memorize this one relation in this MCQ, okay? So the original frequency is equal to under root T and the new frequency is equal to 4 times of the tension. Now if F new divided by F original is equal to 4T divided by T. Now cancel this one and you will get 2. When you apply the under root on 4, you will get 2. Now bring this F here, okay? So the answer will be F is equal to new frequency will be 2 times of the original frequency. Now we know that original frequency is 200 Hertz. Look here. So 2 multiply 200 is equal to 400 Hertz. Okay? This one is the answer. The new frequency will be 400 Hertz. You have to just memorize this one, okay? And then put here F is equal to 4T. And when you apply the under root, you will get that F is equal to 2 times, okay? Now you should ignore this one term, okay? Just ignore this one and the answer will be F is equal to 2. Now you will get to know that from this expression you will get to know that the new frequency will be 2 times of the original frequency, okay? Now write this one, okay? Write this one and put the values. You will get 400 Hertz, okay? The new frequency will be 2 times of the original frequency. 2 times of the original frequency, okay? So here the option B is correct. Now look at the next one. A string with both ends clamped. Now look, it shows that it will give stationary waves, okay? Stationary waves vibrate in 4 loops with frequency of 100 Hertz. The minimum frequency at which the resonance will take place. Now what is minimum frequency? Minimum frequency means the fundamental frequency. And now let's see what is fundamental frequency. Now look at here. The fundamental frequency means that when only one loop form, okay? Here only one loop form. Here L is equal to lambda by 2. Look, this one is equal to lambda by 2. It's lambda by 2. Or lambda is equal to 2L. Now look at here. Let's find the fundamental frequency. We know that F is equal to V divided by lambda, okay? And this one shows the fundamental, okay? Now lambda is equal to 2L. From here we know that its length, okay? Length is from here to here. And this length is equal to lambda by 2. Or lambda is equal to 2L. Now put the values of lambda, okay, here. So you will get the fundamental frequency. Like F1 is equal to V divided by 2 lambda. This is the fundamental frequency. But look here in the MCQ, they have stated that the string make 4 loops, okay? 1, 2, 3, 4. It makes 4 loops, okay? Now, and the frequency is given for 4 loops. We have to find the frequency of only this one, okay? The frequency of only one loop, okay? When we find the frequency of one loop, this is called the fundamental frequency. Now look at here. From here to here, it is length, okay? L. We name it L. And we know that this one is lambda by 2. This one is lambda by 2. Here it is lambda by 2. And this one is also lambda by 2. Now look. Lambda by 2, lambda by 2, lambda by 2, lambda by 2. Now length here is equal to 1, 2, 3, 4. 4 lambda by 2. Okay, here it is the length. But we have to find the value of lambda. Now 2L divided by 4. Now look at here. We have to find the frequency of 4 loops. Okay, this is the frequency of 4 loops, and V is equal to V divided by, we know that F is equal to V divided by lambda, but here we have to find the frequency of 4 loops. V divided by, and here the value of lambda is 2L divided by 4. Now put here, okay, 2L divided by 4. Now bring this 4 here in numerator, okay. So you will get 4V divided by 2L, okay. You will get 4V divided by 2L. Now look here, 4V divided by 2L is equal to fundamental frequency. Just put F1 instead of this one, okay? So the frequency of 4 loops is equal to 4 times of the fundamental frequency. Now you have to find this F1, okay? And we have given only F4 divided, or F4 and 4 loops, okay? So F4 divided by 4 is equal to, now when you divide the, look, 100 hertz, okay? For 4 loops it is 100 hertz. Now when you divide 100 into 4, you will get what? You will get 25 hertz, okay? So the fundamental frequency is 25 hertz. Now listen, you don't have to do all these mathematics, okay? Just memorize this one. For stationary waves, the Fn is equal to n times of the F1, okay? Fundamental frequency. Now look, here we have given F4, okay? Now put here 4, okay? In place of n, put 4, because the loops are 4, okay? The loops are 4, so in place of n, put 4. And here it will be F1. Now you should do this one, okay? After this, you will do this mathematics. So you will get easily the answer, okay? Just memorize this one. For stationary waves, Fn is equal to n times of the F1. This is the formula, shortcut formula, okay? Now look at here, option B is correct, okay? 25 hertz. 23. In resonance tube, the first resonance takes place at a length of 15 cm for frequency of 512 hertz. The second resonance will take place at a length of same set of experiment. Now look what is here. Now look at here, what is resonance tube? The resonance tube is a closed organ pipe, okay? One end is closed, and in this case here the waves form like this, okay? And they have given that the length, first resonance is this one, okay? This is the lambda by 4. Here they have given that the length is 15 cm, and we also know that in terms of lambda it is lambda by 4, okay? In terms of lambda it is lambda by 4. Now the required is the length of second resonance, okay? The length of second resonance, we have to find the length of second resonance. Now look at here, the second resonance is like this, half lambda plus 4 lambda by 4, okay? Now look at here, what you have to do is, we know that from here to here it is lambda by 4, okay? And from here to here, this one is also lambda by 4, and this one is also lambda by 4. Now keep one thing in your mind, that in case of closed organ pipe, you have to consider lambda by 4 for all this, okay? Lambda, you have to take lambda by 4. Here in previous MCQ, that one was standing waves. In case of standing or stationary waves, you have to consider lambda by 2, okay? But in case of closed organ pipe, you have to consider lambda by 4, because here then the mathematics will be easy here, okay? Here we know that from here to here, it is length L. Now the length is equal to 1, 2, 3 lambda by 4, okay? The length is equal to 3 lambda by 4. Now look at here, we also know that lambda by 4 is equal to 15 cm, okay? Lambda by 4 is equal to 15 cm. Now in place of this lambda by 4, put 15 and multiply it with 3. You will get length L2 is equal to 45 cm, okay? Now look at here, if you want to take this one, like lambda by 4 plus lambda by 2, then what will happen? You have to take the LCM of this. You will take like LCM 4, and this one will be lambda, okay? And then after that you will divide these two, you will get 2, and here it will be 2 lambda, okay? 2 lambda. Then you will add this one, 3 lambda by 4. Look, for this one step, if you want to take lambda by 4 plus lambda by 2, you will have to take 3 steps, okay? You will have to do 3 steps for finding this. Now I'm telling you the easy method is this, okay? For closed organ pipe, take lambda by 4, okay? From here to here it is lambda by 4, from here to here it is lambda by 4, and from here to here it is also lambda by 4. So it will be 1, 2, 3 lambda by 4, okay? This one is the most easy method, okay? In case of this one, you have to take the LCM, and additional step will come here, okay? So the time is less, so you have to do this one step, okay? Now look at here, the short formula for finding the length is this one, okay? Look, lambda is equal to 4L divided by 2n minus 1, okay? And also if you want to take the length, if you want to find the length, then bring this one here in multiplication and 4 in division, so you will get this one equation. Now Ln is equal to 2n minus 1. Now look, here in question it is second resonance, the length of second resonance. So in place of this L, put 2, like L2 is equal to 2 multiplied by 2 minus 1, and L1 we know that it is 15 cm, multiply 15 cm. So 2 to the 4 minus 1, you will get 3 multiply 15, okay? But if you do not memorize this one formula, then I think this one is the easy method. Okay, this one is the easy method. Now you have to memorize this one formula. If you don't memorize this one, okay, you don't know the formula of finding, then apply this one method. Okay, apply this one method. In both cases you will get the answer of L2 45 centimeter. Look here, option D is correct. Okay, 24. A string of length 100 centimeter vibrates in 4 loops. Okay, length is 100 centimeter and vibrates in 4 loops. If both ends of string are clamped, okay, clamped, it means that what happens